What is the value of the integer p? Statement 1 says each of the integers 2, 3, and 5 is a factor of p. Another way to phrase statement 1 would be 2 is a factor of p, 3 is a factor of p, 5 is a factor of p. We need to understand something, a basic rule of the divisibility in integers. If they tell me that a certain number n is divisible by another integer a, and the same number n is divisible by another number b, then the only thing I can conclude about these two facts, or any more facts that might exist about the divisibility of n by some other numbers, what I can only conclude is that n must be a multiple of the least common multiple of those factors mentioned individually. This is what I can conclude. Nothing else, nothing more. So if p is divisible by 2, p is divisible by 3, and p is divisible by 5, it follows that p is divisible by the LCM of 2, 3, and 5. But of course, that doesn't determine any single number. We know that the LCM of 2, 3, and 5 is actually number 30. So in the best case, we are confirming that p is a multiple of 30. It could be 30, 60, 120, etc. So not sufficient. Following the same rule to interpret statement 2, we might say that p is divisible by the least common multiple of 2, 5, and 7, which is actually 2 times 5 times 7, or 70. So p equals 70 multiplied by some integer, 70, 140, 210, etc. So not sufficient. If we cross over the information in the two statements, we know that p is divisible by 30, and we know that p is divisible by 70. It follows then that p must be divisible by the LCM of 30 and 70. But that, unfortunately, doesn't signal a unique value of p. This is actually to say that p is divisible by 210, any multiple of 210. There are infinite multiples of 210. So you need to mark option E.